Hello everybody there, my name is part1 and now I am going to solve the fifth question of the Harvard MIT Maths Tournament which was held in spring 2021 and it was particularly held on 6th March of 2021. This is the fifth question of the algebra section or the algebra round, which is according to me is a tough question in terms of the fact that you need to answer this question under 10 minutes. This question is tough. This question is actually saying in words that we need to suppose that x, y, z are three complex numbers of equal magnitude that will basically going to satisfy x plus y plus z is equals to negative of root 3 by 2 negative I root 5, and the product of these three complex numbers is a square root of 3 plus I times the square root of 5. If it is given to us that these three complex numbers can be expanded in the form of x1 plus ix2, y1 plus iy2, z1 plus iz2 under the given conditions that xi, yi, zi for all the natural values of I in between 1 and 3 included both are real, then we need to calculate the value of this below given expression which you can see here. Okay. But yeah, this question is easy as compared to the question which are asked in JEE Advanced for admissions into Indian Institute of Technologies, but still we will try our best to solve this question. First of all, it has been clearly said that these three complex numbers are basically having equal magnitude. Okay, so now what I will basically going to do, I will now going to make this question into a polar form by using Euler's complex representation. So what I will basically going to do, I will take polar, I will take polar considerations here, polar considerations as per Euler representation of complex numbers, as per Euler's representation of complex numbers. Alright, so now, but why I'm doing this is the main question which needs to become in your curious mind. I'm doing this because it has been clearly said that these three complex numbers are basically having equal magnitude, and I'm taking the advantage of it. What I will basically going to do, I will going to suppose that x1 is equal to k times of cos A, and y1 is equal to k times of sine A, where A is basically representing the angle of inclination of the graphical representation of the complex number x, and k is representing the magnitude of the complex number x. As we know that the magnitude of all the three complex numbers are equal, so I can represent y1 by taking its magnitude as k also, but I need to put a different angle in cosine, so I will going to take this time b. So y2 then will going to be k sine b. Similarly, z1 will be equal to k times of cos c, and c2 will be equal to k times of sine c under consideration. Alright. So when I will base, as we all know that x can be represented in the form of x1 plus I, x2, and y can be represented as y1 plus I, y2, and z can be represented as z1 plus I, z2. We can simply take the values of x1 and y1 as the trigonometric values here, which is k cos A plus I times of k times of sine A. Similarly, we will going to do the same thing with y. It will going to be k cos B plus I times of k sine B. Similarly, for z I will also going to do the same. It is equals to k times of cos C plus I times of k times of sine C. So x is equal to k times of cos A plus I sine A, y is equal to k times of cos B plus I times of sine B, z can be represented as k times of cos c plus I sine c here. And we all know that as per Euler representation, we can write this thing. This expression is extremely important to link complex numbers with trigonometry. Okay, so we basically call this as Euler's expression. But how this is derived? This is actually derived by comparison of Taylor expansion of these functions. They are being derived through comparison of Taylor expansions of these functions. Okay, so it is particularly called as Euler's expression. Okay, so interposing this Euler expression in this case and in this case and in this case, we can basically make our way ahead. We can basically write x as k times of e to the power of ia. We can write y as k times of e to the power of ib, and we can write z as k times of e to the power of ic. So this is the thing which we need to keep in mind first of all. And we can also write expressions in this form too. Okay, so this thing we need to take into our considerations here. Alright, moving ahead. Now, we will basically going to take this thing being written here. Okay, x plus y plus z is equal to negative of root 3 by 2 minus I root 5. Alright, so we know that we can write x as k cos a plus k times of cos a plus I sine a. Similarly, we can write y as k times of cos b plus I sine b. Here we will not going to make x, y, z in this form of polar representation because obviously here I is involved and we need to showcase I not in exponent but in the base, which this is showing, but the exponent part is not showing. We are that much clever, we should be that much clever in order to understand this basic difference between expressing and the use of the expressant sometimes. So it will going to be z will going to be k times of cos c plus I times of sine c. This whole thing or this whole shit is equals to negative of root 3 by 2 negative of I root 5. By comparing the real and the imaginary coefficients, by comparing the real and imaginary coefficients of the above expression, coefficients of the above expression, we shall get that cos A plus cos B plus cos C is equals to negative of root 3 divided by 2k. Okay, this is the first thing. And sine of A plus sine of B plus sine of C is equal to negative of root 5 by k. We need to take this into our utmost consideration. So this is also important, that's why I'm highlighting this in green. There's a significance of anything that I do. Bang, जो कौन कुत्ता भौंक रहा है तब से? Here, this xyz can be written as square root of 3 plus I times the root 5. Okay, as you can see from this expression that we have written here, we can do this sometimes. Now, but now they are in multiplication, so it can be leading to the addition of the exponents. So addition of the exponent we can support that. That's why in this expression we will basically going to use the Euler compressed polar representation of the three complex numbers x, y, z, which is basically been given to us. Jesus Christ! बहनचोद कौन तब से कुत्ता भौंक रहा है? तो यहाँ पे x in this we can basically represent x y z in this case as the compressed Euler representation of these three things. All right, as they're in product, so it can simply be led to the addition of the exponents here. Hey, chupe! So proceeding with the thing, I will basically going to do k into e to the power of ia multiplied with k into e to the power of ib multiplied with k into e to the power of ic. Okay, so it will be like root 3 plus I root 5. It will be k cube e to the power of I a plus b plus c. It is equals to root 3 plus I times of root 5. So as we know that e to the power of I theta can simply be represented as cos of a plus b plus c plus I times of k cube of sine of a plus b plus c here, guys. It is root 3 plus I times of root 5 in this expression. Comparing the real and imaginary coefficient, comparing the real and imaginary coefficients here, we can simply get as the answer in this expression as the cos of a plus b plus c is equals to root 3 by k cube, and sine of a plus b plus c is equals to root 5 by k cube. Now one thing that you need also to consider here that by magnitudinal comparison, so magnitude needs to be compared in this case.